Hi, year 13, just following on from our lesson the other day, as promised, the video now for the aerobic system, and this will help you with the work that we were doing. And I've tried to adapt the slides or keep in slides things that will appeal to the scientific nature of something that we found in the lesson, but also we're going to make it very explicit what you need to know, what you have to know, and hopefully those of you that aren't going to get bogged down in the details of things will just discard that stuff. Okay, so the aerobic system, as we talked about in lesson, this obviously here is our lactic acid system. And if you remember that when in the lactic acid system, when we went through all of this process and we got to the stage where pyruvic acid was being created, I said to you that when there was no oxygen present, pyruvic acid was then formed into lactic acid, and our lactic acid would be over there. But now we're talking about when oxygen is present. So when oxygen is present, pyruvic acid is turned into a product called acetyl-CoA, and that's through pyruvic acid joining with coenzyme A to form acetyl-CoA. And this is the starting point of the aerobic system. Okay, 2 molecules of ATP are resynthesized during there, and then like you see it says pyruvic acid combines with coenzyme A to form acetyl-CoA. You then get acetyl-CoA, which combines with oxaloacetic acid, sorry it's early, to form citric acid, and it's the citric acid that goes into Krebs cycle. If you look at page 11 in your textbook, it's a slightly more basic diagram that'll tell you what you need to know as well. Right, what you need to know about Krebs cycle is that citric acid is then further broken down, and this happens in the mitochondria. So rather than the sarcoplasm of the muscle, we're now talking about the mitochondria. So when it talks about in your book the site of the reaction, it's the mitochondria that you need to worry about. So this citric acid goes into Krebs cycle. Krebs cycle is incredibly detailed, incredibly difficult. What you need to know is that it produces carbon dioxide, and this is then removed. So during Krebs cycle, carbon dioxide is produced and removed. Oxaloacetic acid is regenerated, so it goes back into that system, and we get a yield of 2 ATP. The key point, however, though, is the hydrogen atoms that are produced through oxidation. So they go, and that goes into the next stage. So if you just really quickly look at that, we get carbon dioxide produced, hydrogen atoms are removed through oxidation, 2 molecules of ATP are produced, and then they get that oxaloacetic acid being regenerated. Hydrogen then go into, and this is what they just need to know here, that in the matrix of the mitochondria in the cristae folds. Now Matty, this slide is especially for you because I know you'll want to know exactly what's going on. However, I'm conscious you might not be able to, you will be able to see it now. Okay, for those of you that are not interested in how it works and just want to know what happens, basically hydrogen moves down something called the electron transport chain. That's your mark winner. So hydrogen goes down the electron transport chain, and created there are oxygen, water, and we get 34 ATP. You do not need to know any of this stuff here, 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 any of this stuff here. But Matty might want to, so I've left it in for that reason. Again, you don't need to know this, how about the hydrogen being split and such like. All you need to know is that hydrogen goes into the electron transport chain, and we get energy, oxygen, and water out of that. All right, you do need to know that it takes place in the mitochondria. You don't need to know that. You do need to know that, and that you do need to know, but you just need to know that water is created. So the total energy yield for the aerobic system is 38 ATP. 2 from the aerobic glycolysis, which is the start, remember, of our lactic acid system. 2 from Krebs cycle, and then 34 from the electron transport chain there at the end. This is at the bottom. Again, it might help some of you, it might not. Effectively, what you've got overall is glucose plus oxygen equals carbon dioxide, water, and energy. And that above it is just the chemical representation of that. Glucose plus oxygen equals carbon dioxide, water, and energy. And what we just need to be aware of, I've skipped to this slide, the disadvantages of the aerobic system, and then also we need to know the advantages as well. But if we start with the disadvantages, the system, it doesn't happen immediately, and we talked about that in lesson. There is a little bit of a time lag with this, so you get a delay in oxygen being transported from the lungs to the working muscles, so you don't get the ATP immediately. Advantages, obviously, we get energy for a long time. It says to an hour there, but we know that we have endurance athletes that use aerobic system for considerably longer than that. Excuse me. We get 30 ATP from one mole of glycogen, and there are no harmful byproducts, chemical reactions. We just get carbon dioxide and water. I've got this slide for you again as a handout, so that hopefully will help you as we're going through things. But for the time being, I don't want to give you any more detail. I don't want any more confusion. We'll talk about it and clear everything up in lesson. All right. Thanks very much.